Greetings, M squared here. Today we are going to talk about quadratic functions, the vertex form of quadratic functions. So I'm just going to go over some notes on our little express sheet that gives you all the information you're going to need. And I want you to notice I said y equals f of x. Remember, those two are the same thing. You might see y equals an equation or you might see f of x equals. Either way, you need to know that they're the same. Notice that the A that we've been talking about that tells us whether the graph opens up or down, whether it's vertically compressed or vertically stretched, is in front of the parenthesis. You have an X. That's an actual X, just like this is an actual Y. All the other letters you see will have numbers with them. You won't see an H or a K or an A. You're going to see numbers. Notice that the X minus H is in the parentheses and outside it's squared, and notice that it says minus H. So if H is 3, it's going to say minus 3. If H is negative 2, it's not going to say minus and negative 2. It's just going to say plus, because minus and negative is plus. So we'll talk about that a little bit more later. But our goal today is to be able to look at the graph and write the function. That's our goal. But we're going to go over some things first. So first of all, we've already done this, so the really quick review. How does A affect the graph? A, if it's greater than 0, opens up. If it's less than 0, if A is less than 0, it opens down. If the absolute value of A is between 0 and 1, it's vertically shrunk, or we said compressed. That's the word we used. I should have changed that. Compressed. That is a better word. And vertically stretched if the absolute value of A is greater than 1. That we've already done. Now we've talked about where to find the vertex on a graph, but we haven't talked about it in terms of H and K. Notice that if you have an equation like this, you're going to look for the x-coordinate of the vertex right there and the y-coordinate right there. HK is our vertex. So in this equation right here, A is 3, right? So what does that tell us? It tells us that it opens up and it tells us it's vertically stretched. The vertex is H. Remember, that's minus H. So H is 4 and K is negative 7. So here we go. We have 4, negative 7 as our vertex. So you should be able to look at an equation and in vertex form and see the vertex. That's why we call it vertex form, because you can see the vertex. Axis of symmetry, remember, is always an equation, and it's always whatever the x-coordinate of the vertex is. And since we're calling that H in vertex form, then our axis of symmetry is going to be x equals H. Domain, remember we talked about it. Domain for all the kinds of parabolas we do in Algebra 1 is all real numbers, okay? Range depends on the y-coordinate of the vertex, and it's either greater than that or less than that. And so it depends on if it opens up or down. If A is negative, then we know it opens down, so it's going to be less than that y-coordinate of the vertex. And the y-coordinate is K. If A is greater than 0, we know it opens up. So we're going to say the range is y is greater than or equal to K. The x-intercepts are found, the y-intercepts, you can find that by making x 0. You just plug an x, a 0 in for x and solve for y. That's how you can find your y-intercept. We'll talk about that later. And then x-intercepts, which we'll talk much more about next chapter, but we talked about them, we just found them, but we're not going to talk about how to find them from an equation until next chapter, but just so you know what they are. Okay, so keep that little sheet handy. What we're going to talk today about is patterns, because we need to be able to look at these equations, these graphs, and write their equations. We're going to write them in vertex form, so I already know it's going to be y equals, I'm going to have a parenthesis with an x right there. I already know that. I'm going to have a number here for A, I'm going to have a number here, the vertex, x-coordinate, vertex, y-coordinate, right? That's always a minus sign, but we'll get to that in a minute. Okay, so first of all, I want to talk about the patterns. What patterns do you notice? This is y equals x squared, right? We have our x and our x squared, and I've already filled out these kind of charts for you so that we don't have to do it and we can just look at the pattern. So what I want you to notice is that the distance between these. Remember, we did this when we were doing linear equations, and we found out that it was always like the same distance. It was always 3 or always -5. And that told us it was a linear when it was adding the same thing every time. So quadratic functions are a little bit different. What's the difference between 9 and 4? Well, we went down 5, then we went down 3, then we went down 1, then we went up 1 and up 3 and up 5. Now here's the cool thing. To know if something's quadratic or not, this is the difference. This is called the first difference. If you take the second difference, I want you to notice what happens. Like, what's the difference between these two? I'm going up 2, up 2, up 2, up 2, up 2. So if it's a quadratic equation and you have a table, if you find the first difference and then you find the second difference, that's what this is called, you're going up 2 each time. And when the second difference is always the same number added each time, that's your clue that it's quadratic. So it's kind of cool how these patterns work. But I want you to notice that when you're at the vertex, I'm going to highlight that vertex, I can tell it's the vertex because that's where the numbers start going down and then start going up. So that's how I can tell. So I'm going to highlight the vertex for us. And then I want you to notice, when I went up 1, I went over. When I went over 1, I went up 1. When I went over 1 more, here's my over 1 more, I went up 3. When I went over 1 more, I went up 5. And if you look at that pattern, then that's how you can tell what A is. Because notice that A is 1. A equals 1. Here A equals 2. So let's notice the difference. What is different about this pattern? Well, let's look. That's minus 10. That's minus 6. That's minus 2. And then we go up 2, up 6, up 10. Now notice the second difference. That's up 4, up 4, up 4, up 4, up 4, right? So that's how we know it's quadratic. But here's what I want you to notice. When this one went 1, 3, 5, this one went 2, 6, 10. You see that 2 right there? It's actually multiplied by the x squared. So I actually, if you take 1 times 2, you get the 2, 3 times 2, you get the 6, 5 times 2, you get the 10. So to be able to recognize this pattern, I usually just do the first ones, right? I go up 1 over 2. I'm going to talk more about this later, but it's kind of cool to look at the pattern. Okay, now what do you think is going to happen with 3? If on 2, you just multiplied that one by 3, what do you think is going to happen over here? Probably the same thing, right? Except it's going to be times 3. So let's look. 27, that's down 15. Then I'm down 9, and then I'm down 3. And then it's 3, 9, 15 positive. But notice what happened. If you look at this one, that was 5, but if you times it 5 by 3, you get that 15. If you times 3 by 3, you get the 9. It's really important to recognize the patterns because sometime you're going to have to look at a table and write the equation from that. Crazy, huh? You can do it. Okay, and the 4 pattern is just going to be that times 4. I won't worry about it, but you can look at it yourself. What if it's a half or a third? What's going to happen? Well, let's see. This is down 2.5. If I write that as a fraction, that's, let's see, 5 halves. Is it? Okay, yep. Sorry. And this is down 3 halves, or 1.5, and this is down 1 half. Now I want you to notice, here's my vertex, right? Here's my vertex. I want you to notice these top numbers, 1, 3, and 5. The 1 half was multiplied by 1, the 1 half was multiplied by 3, and the 1 half was multiplied by 5. These numbers right here from our parent function. So it's kind of cool how it even works with fractions. So on this one, right, you're going to take the 1/3 times the 1, you get 1/3, then you take the 1/3 times the 3. So this distance right here is, let's see, 3/3, right? And this distance right here, 4/3 is 5/3. So we still get that 5, 3, 1 pattern. Okay. Anyway, I think patterns are cool. You might think it's a little strange. I made it simpler for you. This little thing right here is just some of the popular patterns, right? So we're getting ready to graph, but I want you to notice these patterns. Sometimes it's hard to see if you go up 1 and up, over 1 and up a half. Sometimes that's hard to see. So the 1 half and the 1/3, it kind of works like this. The other ones are over 1, up 1. That means A is 1. If you go over 1, up 2, A is 2. If you go over 1, up 3, A is 3, etc. If you go over 1 and up a half, you're at a half, but you don't always know that. So if you go over 2 and up 2, you know that it's 1/2. If you go over 3, up 3, you know it's 1/3. Would work for 1/4, 1/5, whatever. We've talked about that a little bit, so that if you weren't here the other days, that might be a little more confusing. So here's what we're gonna do. We're gonna steps to writing equations. We're gonna find our vertex. We're gonna find A using these patterns. We're gonna note if A is positive or negative, because that makes, we can tell that by if the graph is opening up or down, and then we're gonna write our equation. So here we go. We're gonna use our little pattern. So first of all, find the vertex. What is my vertex? My vertex, can I get all of that on the screen? Let's see. There we go. My vertex for this one is 1, 2, 3, 1, 2, -3, 2. Why is that important? Sorry, you can't even see that. Why is that important? Because the H, remember this is H and this is K. So I'm going to take my K, my 2, and say plus 2. I'm going to take my H and say minus a -3. Okay, it's a minus a negative. That means it's going to be a positive. So that's how I get the inside of the parentheses and this one. Now it's about A. So I've got to find A. I use my pattern. So I start at the vertex and I go over 1. I always start at the vertex and go over 1. And then I go down until I hit the graph and I count. That's 2. So I know my A is going to be 2, but since it's upside down, since I went down 2, it's going to be -2. And that is how I write the equation. Okay, we're going to try the next one. Y equals, remember the things we already know. We know there's a Y equals, we know there's a parenthesis with a squared, we know there's an X and a minus. Okay, now the first thing is we find our vertex. So what's my vertex? Here we go. Over 4, down 3. Over 4, down 3. That's my vertex. So this is my H, this is my K. So I come up here, it says minus H, so I say -4. It says plus K, so I have to say plus a -3, but instead of plus a -3, I just say -3. Then I've got to find my A. I know it's going to be positive because it opens up. So I go like this. Go over 1, up, 1, 2, 3. It's 3. Now if I kept going, remember our little pattern up here for 3, the next thing would be 9. I would go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Somewhere in there. I think it's right there. I counted wrong. All right, so what is A? It's 3. So I put a little 3 there. All right, last one, and then you're on your own. First thing I do is find my vertex. My vertex is, let's see, I went over 3 and down -4, so that's my vertex. So Y equals X minus 3 squared minus 4. And now I find my A. So notice that it's counting. I go over 1, up, ooh, I don't know, is that a half, is that a third? So I say, okay, well, what if I go over 2? Am I up 2? No, that's tricky. Why did I give you such a tricky one? Let's see, I'm counting by ones. So here is where it touches. And let's see, over 1, up, that looks like a third. I'm gonna say it's a third. So let's go 1, 2, 3, 1, 2, 3. Yep, see, I went over 3, up 3, so I know it's 1/3. It's positive because it opens up. So see how that was tricky? I wasn't sure. It's not 1/2, it's less than 1/2, probably 1/3. So then I remember, see my pattern? Up 3, over 3. Okay, so I'm gonna go over 3, 1, 2, 3, up 3, 1, 2, 3, and it was right there. So I know that it is 1/3. All right, good luck with that. M squared signing out.